Hello, welcome to episode 4. There has been a change in our scheduled programming. We're actually going to spend this entire episode on simultaneous equations. I was going to look at some absolute value stuff as well, but that got bumped for a later episode because I just felt like it's going to have a more relevant place later. Let's start with the question, what are simultaneous equations? The way I explain this with my students is I say an equation can be thought of as a rule. So if we take this as our example, y equals 2x plus 1, that's a rule. Any point on this line, the y coordinate must be double the x coordinate plus 1. Okay, that's the rule. We have to follow the rule for this line. I've listed a pair of points here, 1, 3 and 10, 21. Pause and check. Both of them do satisfy the equation. They follow the rule. Here are a pair of points. Pause and check. They don't satisfy the equation. If you substitute these x and y values into this equation, it's not true, right? 0 does not equal 2 times 1 plus 1. It's not true. They don't follow the rule. If we graph y equals 2x plus 1, we get this guy. And the reason I'm showing you this is because it's really important to understand what we're doing with simultaneous equations, to understand that every equation has a graph. Every point on this line satisfies the rule y equals 2x plus 1. Okay? Every point that satisfies the rule is on this line. Now, you might think I just said the same thing twice, but I didn't. I said two different things. Every point that is on the line satisfies the rule. And every point that satisfies the rule is on the line. Okay? Every point that is not on the line will fail to satisfy the rule. And every point that fails to satisfy the rule is not on the line. What this means is the rule and the line, they're the same thing. Take another example, y equals negative x plus 4. Here is our line. Every pair of x and y coordinates that satisfy that is on this line. Every point on this line will satisfy that rule. So the rule defines the line represents the rule. This is why when I explain this to students, I say that an equation and its graph are two sides of the same coin. They're two ways of communicating the same information. They are the same thing from two different perspectives. Now I'm going to graph both of those on the same line. They have different gradients. This one has a gradient of -1. This one has a gradient of 2. Because their gradients are not the same, they're not parallel, and because they're not parallel, they must intersect somewhere. We can see quite easily that this point of intersection is going to be at an x value of 1 and a y value of 3. Cool. These two lines intersect at the point 1, 3. At this point 1, 3, both rules are satisfied simultaneously. Okay, this is where the term simultaneous equations comes from. We're looking for a point which satisfies more than one rule at the same time. Algebraically, we can verify this real quick. If we take our first equation and we substitute in that y is 3 and x is 1, this is true. 3 does equal 2 times 1 plus 1, that's 3. And 3 does equal -1 plus 4, that's 3. So these equations are both satisfied by this point. This point is true for both rules. In fact, because these lines only cross in one place, there is no other pair of x and y coordinates, no two numbers x and y, which will be true in both of these equations. Doesn't exist. So this is an easy pair to solve graphically because when we looked for the point of intersection, it was on like a whole number. It was on the corner of the grid lines. Sometimes the point of intersection could have a coordinate which is a fraction or a decimal or a surd even. And in order to find the point of intersection when it's not so easy to see it, we need to know how to solve simultaneous equations algebraically too. So instead of graphing them and just looking for the point, we need to know how to do it with algebra. There are two methods we're going to use. The first method we're going to cover here is called the substitution method. Once we've gone through the substitution method, we're going to learn the elimination method. These are taught as two different methods. Really, once you get good at them, you're not going to think about, am I using the substitution method or am I using the elimination method? You're just going to think, or I'm solving these two equations simultaneously. But to help you grip onto something and really understand these techniques well, first, we're going to give them names and we're going to look at them each in isolation. Okay, so let's take the two equations that we looked at in our last example. We know that the values of x and y we're looking for must be able to work in both equations. In fact, we already figured out what they were by looking at the graph, but shh, let's pretend we didn't. The first thing that we can do is we know that the y value that we're looking for is going to be equal to itself. Now, hold on. You might think this is stupid, but I'm going somewhere with this. Because the y on the left-hand side, I know, is meant to represent this y, and the y on the right-hand side is meant to represent this one up here. But they're equal. They're the same value. So if y equals y, then what I can do is on the left-hand side, I can replace that y with what I know that it's equal to, which is 2x plus 1. And on the right-hand side, I can replace that y with what I know it's equal to, which is negative x plus 4. And so the equation y equals y becomes the equation 2x plus 1 equals negative x plus 4. Now what's cool about this is now we have an equation with just one variable, x. So we can solve that pretty easily. 2x plus 1 equals negative x plus 4. We can collect our like terms. We're going to get that 3x equals 3 or x equals 1. Cool. Once we know x, we can substitute it into either of the original equations to find y. For the first equation, y equals 2x plus 1. If x is 1, we get that y equals 3. And for the second equation, y equals negative x plus 4. If x is 1, we get that y equals 3. This form of substitution we've just done is the easiest sort of example we can get because both equations were already written in gradient intercept form. So let's look at a slightly different case. In this case, they're not both in gradient intercept form. So what we're going to do here is we're going to take the value of y from the right-hand side of the first equation. Y is 3x plus 2. And we're going to substitute that value into the second equation. We're going to put it in here. So this becomes 2x plus 3x plus 2 equals 8. So now we can solve this to find x. We'll have 5x plus 2 equals 8, which means 5x equals 6, or x equals 6/5, which is 1.2. Now we can substitute it back into the original equations. So we can say y equals 3 times 1.2 plus 2, which is 3.6 plus 2, which is 5.6. If we use the other equation to substitute in, we would say 2 times 1.2 plus y equals 8, or 2.4 plus y equals 8, or y equals 5.6. Again, we get the same answer. This means that the solution for these simultaneous equations was the point 1.2, comma, 5.6. Or I prefer to write them as fractions personally, so I would say 6 over 5, comma, 28 over 5. Like that. Basic idea is first, we use one equation to find the value of one variable in terms of the other. AKA, we rearrange one to say y equals. Then we substitute that value into the other equation. Everywhere that there's a y in the other equation, we put the thing that y equals. Then we solve that equation to find the value of x. And we take that value of x, we put it back into one of the two original equations to find y, right? Each of these 4 steps can have multiple little steps within it, which means solving simultaneous equations can be one of the more involved types of questions that you can be asked. You can have a lot to do. And for this reason, I just want to warn you to be super careful to make sure that you are finished when you stop your working out. It's really easy to make a mistake of the type that you do a bunch of calculation and you get x equals and you just think you're done because you're used to solving equations and getting x equals. But you have to remember, when you're doing a simultaneous equation, you still have to find y. And once you found y, you might not be done yet because you still might need to answer the actual question you've been asked. Okay, this was a quick overview of the substitution method. Now, I want to talk about the next one, which is the elimination method. This method is really, really, really easy in some cases. If you try and use it in the wrong situation, it becomes really, really, really messy. When you get given two equations to solve simultaneously, you want to be on the lookout for when you have the same quantity of a variable in both equations. So I've given this example here, and I just want to highlight that we have this 2y in both of those equations. So what we're going to do is we're going to combine these two equations in such a way that those two y's will cancel out. To achieve that, I'm going to subtract the equations. And when you subtract equations, basically you subtract the left-hand side from the left-hand side and you subtract the right-hand side from the right-hand side. The one thing that's really important is you have to keep track of which equation comes first and which equation comes second in the subtraction. So if this is equation 1 and this is equation 2, and I'm going to do 1 minus 2, then it's going to look something like this. 3x plus 2y minus negative 4x plus 2y. Notice that I use brackets. Even when you might think you don't need the brackets, is always a good habit to have. They don't do any harm. On the left-hand side, we have equation 1 minus equation 2. On the right-hand side, we have equation 1 minus equation 2. It's really important those match. If those don't match, you will not get the right answer. Let's see what we can do with this. So that's going to become a 7. Over here, I'm going to leave this untouched for a moment, but this is going to become plus 4x minus 2y. And the beauty of this is that this plus 2y and this minus 2y, they just oppose each other. They disappear. So I get that 7x equals 7. And how handy is that? That means x is equal to 1. We've solved for one variable. What we can do next is substitute it back into one of the original equations to find the other. It doesn't matter which equation you substitute it back into, but I recommend trying both because if you get the same answer, that means you're on the right track. And if you do not get the same answer, that confirms that something's gone wrong. Just by doing one extra check, by substituting into both equations, you're checking your working out as you go and you're going to catch mistakes. Let's see how we went. I think we should be fine. We had 3x plus 2y equals 12. And we just discovered that x is 1. So that means 2y will be equal to 9. Or in other words, y will be equal to 9 over 2. And then if we use the other equation to check, we have negative 4x plus 2y equals 5. Negative 4 times 1 plus 2y equals 5, which means 2y is going to be equal to 9. And so again, y is going to be 9 over 2. Because these two match, that means we're on the right track. Now, I want to caution you, we're not done. We have the tiniest thing left to do, which is we need to take our two answers and we need to put them as a coordinate. So the answer to this question would be the coordinate 1, 9 on 2. This is our answer and we are done. So that's a really quick overview of the elimination method. Now I'm about to give you more examples of that because I'm about to go through a lot of examples. Today's video is going to have a lot of example questions. So what you need to do as I go through each one is you need to pause the video, try it yourself, and then watch my solution. As always, my solutions are going to go very quickly, so take the time to do it yourself before you watch my solution and then check your answers. If you don't get the right answer, go through my solution more slowly, copy it out, and make sure you understand how to do it correctly. So the first thing that I noticed in this one is that we have 7y and 7y. Those are the same, so I think, elimination method. But I do also notice that one is plus and one is minus. So this is slightly different to the example we looked at. The example we looked at had two that were positive, and so we did a subtraction. Because these are opposite, one is positive, one's negative, I'm going to add them together. So we have equation 1 and equation 2, and I'm going to calculate 1 plus 2. So that's going to be x plus 7y plus x minus 7y equals 5 plus negative 9. Okay, so this will become negative 4. Here we're going to have 2x and the 7y's cancel, and so we get x is equal to negative 2. We're partway there. We've figured out one of the variables. So we can say negative 2 plus 7y equals 5, or in other words, 7y equals 7, so y equals 1. Now, we can, at this point, we can just say, we're done, because we know that our coordinate is negative 2, 1. But I'm going to take it a step further, and I'm going to double check. So I'm going to use the other equation here, negative 2 minus 7y equals negative 9, which means negative 7y equals negative 7, which again means y equals 1. Because these two match, that means we're on the right track. Just for fun, I want to graph each of these. X plus 7y equals, and x minus 7y equals negative 9. And we can see that the point of intersection of these two is where x is negative 2 and y equals 1. So we're definitely on the right track. In this case, I can see that we have 4x in both cases. So I'm going to use the elimination method. I'm going to do equation 1 minus equation 2. So we've got 4x minus 5y minus 4x minus 2y equals 30 minus 24. Now, I notice that this minus is going to become a positive when we remove these brackets. So the 4x's will cancel, and this will become negative 5y plus 2y, and then over here we have 6. So we're going to get negative 3y equals 6, or y equals negative 2. Now let's sub it back in. So just real quickly, I'm going to call this equation 3, and I'm going to do this. I'm going to say, let's take equation 3 and sub it into equation 1. So that's going to say 4x minus 5 times negative 2 equals 30, which becomes 4x plus 10 equals 30. So 4x equals 20 and x equals 5. Okay, let's just check really quickly. If we take equation 2 and we have 4 times 5 minus 2 times negative 2, that's 20 plus 4, which equals 24, which is exactly what it should equal. So we've confirmed with the second equation that we have the correct answer. So now we have to give our answer. The answer is 5, negative 2 as a coordinate like that. Let's see what that looks like on a graph. And we can see our point of intersection here is at the point 5, negative 2, which is exactly what we said it would. When I look at this one, it doesn't immediately shout out elimination method because we don't have the same number of x's or the same number of y's. So we could use the substitution method, but I do want to show you that the elimination method can still be used. So what I notice, if we took equation 1 and multiplied it by 3, right? So I'm going to say equation 3 is 3 times equation 1. Now we have 9x minus 3y equals 15. And now we have this plus 3y and this negative 3y. So I'm going to add these two together. So I'm going to do 2 plus 3, which means 5x plus 3y plus 9x minus 3y equals negative 8 plus 15. And so that will become 14x equals 7. So x is going to be equal to 1/2. Now I'm going to substitute this, let's call this 4. And so let's substitute 4 back into 1. So we have 3 amounts of 1/2 minus y equals 5. So if we subtract 3 halves from both sides, we're going to get that negative y is equal to 3 and a half. Let me put that as an improper fraction so we don't get confused, which means y is going to be equal to negative 7/2. Now we can check this with equation 2. I'm just going to check it up here. I'm going to say 5 times 1/2 plus 3 times negative 7/2 equals negative 8. Let's see. So we've got 5/2 minus 21/2, which is going to be negative 16/2, which is equal to negative 8. Okay, so we know our answer is correct because we checked with two equations, and so now we just give our answer as the x coordinate and the y coordinate, like so. Let's check it. And our point of intersection is at 1/2 and negative 3.5, or negative 7/2. So again, we can see that we have the correct answer. This one's going to be a little bit harder to apply the elimination method because we can't easily multiply the numbers from one into the other. That doesn't mean we can't use the elimination method. For example, I could multiply the first equation by 9 and the second equation by 5, and then we would have 45x in both of them. But I'm not going to use the elimination method that way. I'm going to use the substitution method. The first thing I'm going to do is I'm going to rearrange the first equation. So it's going to say y is negative 5/2x plus 9/2. I'm going to call this 1 star. And I'm going to substitute that into the second equation. So we go 1 star into, so we're going to get 9x minus 7 amounts of negative 5 over 2x plus 9 over 2 equals negative 5. So we want to solve this now for x. So let's start by expanding our brackets and collecting our like terms. We have 9x plus 35 over 2x minus 63 over 2. That is equal to negative 5. Okay, so 9x, if we had that over 2, that would be 18 over 2. So if we add that to 35 over 2, that becomes 53 over 2. Now, if 5 was over 2, it would be 10. So when we add 63 halves to negative 10 halves, we're going to get 53 halves. Ooh, and this is nice. That just means x is equal to 1, which I'm going to call our equation 3. And now we can easily check our answer by doing 3 into 1. So we say 5 times 1 plus 2y equals 9, which means that 2y equals 4 or y equals 2. All right, that's a good sign. Let's just check it with equation 2. So if we say 9 amounts of 1 minus 7 amounts of 2, well, that is equal to 9 minus 14, which is negative 5, which is exactly what we would expect. So our answer is going to be 1, 2. Let's graph them and see what we get. We can see here that our point of intersection is at 1, 2, which is exactly where we said it would be. In this case, what do I want to do? Substitution or elimination? I'm going to do an elimination one here. I'm going to multiply the first equation by 2 to get 10m, and I'm going to multiply the second one by 5 to get 10m again. And then we're going to have equation 1 star. We're going to have equation 2 star. So 1 star will be 10m minus 12n equals 24, and 2 star will be 10m plus 45n equals 100. So now I'm going to do 1 star minus 2 star, which means 10m minus 12n minus 10m plus 45n equals 24 minus 100. 10m's cancel out. Negative 12n minus 45n is negative 57n, and that's going to be equal to 76, negative 76. So n is going to be equal to 76 over 57. This can be simplified. That's 4 over 3 if we divide both by 19. Let's call this equation 3, and then let's sub that back into equation 1. 3 into 1 gives us 5m minus 6 times 4 over 3 equals 12, which means 5m minus 8 equals 12, which means 5m equals 20, or m equals 4. So let's just check that with the second equation. 2 times 4 plus 9 times 4 over 3 equals 20. This is going to be 8 plus 12 equals 20, and that is true. And so we can say our final answer is, if we had x and y, we would know which order to put m and n in. I would say we have two options for how to write our answer this time. We can either write m equals 4, n equals 4 over 3, or we could use the order, alphabetical order of them, just like with x and y. We could say, let's put m first, 4 over 3. But to be honest, I think this is the safer way to answer because there's less chance of confusion. If you did it the second way, then you could clarify by saying these are equal. So the first one, the 4, is the m value, and the second one, the 4/3, is the n value. And if we look at our point of intersection here, we have 4 and 4/3. So we are doing very well. This one is a little trickier. The reason this one is trickier is we need to expand those brackets and collect our like terms before we can either substitute or eliminate anything. So I'm not even going to call these number 1 and number 2. I'm going to process them each a little bit first. So the top one, if I expand the brackets, we're going to get 3 amounts of x and negative 3 amounts of y. So this will become 5y. So you have 3x plus 5y equals 42. And this one, we're going to have minus 1 amount of x, and those two y's become positive. So we'll have 8x plus 2y equals 78. So these are our equations 1 and 2. Because the numbers on the right-hand side are really big, I don't want to use elimination. I want to use substitution. What I'm going to do is I'm going to rearrange number 2. I'm going to say y equals negative 4x plus 39. So this can be 2 star. Now we can substitute 2 star into 1, which is going to give us 3x plus 5 times negative 4x plus 39 equals 42, which means we're going to have 3x minus 20x plus 195 equals 42, which means negative 17x is going to be equal to negative 153. And I'm going to bet that 17 is going to go into 153. That's going to be 19 amounts of 17. Sorry, 9 amounts of 17, because one more amount of 17 gets us to 170, which means that x is going to be equal to 9. That can be our equation 3. Let's take equation 3 and sub it back into which one will be easier. I'm going to go with equation 1. So we'll say 3 amounts of 9 plus 5y equals 42, which means 5y equals 42 minus 27, right? That's those three amounts of 9. 42 minus 27 is 15, so y is going to be equal to 3. All right, let's double check that. I'm going to take equation 2 star this time. So negative 4 times 9 plus 39 is equal to 3, which is y. Cool. So our x and y answer is 9, 3. Let's graph this. Drum roll. We can see that our point of intersection is right here at 9, 3, which is exactly what we found algebraically. We're killing it. Now we have some that look a little bit crazier. Again, like the example we just did, I'm going to process these a little bit before I try and calculate anything. For the first equation, I'm going to multiply everything by 6 because that will get rid of the denominators. So we'll have 3x minus 9 equals 4y plus 2. I'm doing some steps in my head. If I'm making a mistake, let me know in the comments. If you don't know what I'm doing, go through the working step by step yourself. All I'm doing is multiplying both sides by 6. And the second one, I'm going to multiply both sides by 10. So this will become 6x minus 2 minus 10y minus 5 equals 10. If I made a mistake, let me know in the comments, or I'll find out soon enough. Otherwise, if you're confused, go through it step by step. I have 3x in the first one and 6x in the second one. So what I'm going to do, 2 amounts of 1 minus 2. So that will become 6x minus 9, no, minus 18, because I'm doubling it, minus 6x minus 2 minus 10y minus 5 equals 8y plus 4 minus 0. 6x's will cancel, so I'm going to have negative 18, and then this negative 10y will become positive, and this negative amount of 7 will become positive, and that's going to be equal to 8y plus 4. So let's collect our like terms. I'm going to put all the y terms to the left and all the constant terms to the right. So we're going to have 2y, and then over here we're going to have a negative 11. We add that to 4, so that's going to become 15. So y is going to be equal to 15 over 2, or 7.5. What do I want to substitute that back into? I'm going to, so this is equation 3. I'm going to substitute it back into equation 2. 6x minus 2 minus, so 15 over 2 is 7.5. If we take 10 amounts of that, that's 75. Minus 5 equals 10. So in total, we've got negative 82. Let's add that over here. That means 92 equals 6x. Or x equals 92 over 6. I can halve both of those. That's going to be 46 over 3. Now that does not look like the kind of answer I want to be getting. Maybe I've made a mistake. So I'm going to try and catch my mistake by checking with both of these two original equations. So if I take 3 amounts of 46 on 3 and go minus 9, is that equal to 4 amounts of 15 on 2 plus 2? Well, that's going to be 46 minus 9. And then here I'm going to have 30 plus 2. And that is not true. 47 does not equal 32. This means something's gone wrong. Okay, so we can check our answers at this point. What I'm going to do is I'm going to go back to the very start. I'm going to make sure I haven't made a mistake up here. So when I multiply both sides by 6, the 6 here is a 2 and a 3, and the 2 will cancel with that, which will leave a 3 out the front, so we'll get 3x minus 9. Same kind of thing happens over here. We're going to get 2 times these things, so we'll have 4y plus 2. Okay, so equation 1, that's correct. Here, same kind of thing happens. This will be multiplied by 2, the numerator. This will be multiplied by 5. So 6x minus 2 minus 10y minus 5. Notice that this is a minus because it's affected by this guy, equals 10. Okay, I'm quite confident with equation 2 up there. So then the next question is, what happened when we did 2 times equation 1, and then we subtracted equation 2? So, that's obvious. That should have been a 10. I read it as a 0. So let's repeat these steps. Over here, we're going to have 8y minus 6, right? Because plus 4 minus 10. Over here, we're going to have 10y minus 11. So that will be 2y equals, negative 6 plus 11 is 5. Y is equal to 5 over 2. Now that seems a lot more likely to me. If y is 5 over 2, it doesn't really matter which equation I go for. I'm going to go for equation 1. So let's take 3 here and go 3 into 1, which means 3x minus 9 is equal to 4 amounts of 5 on 2 plus 2. In other words, 12 plus 9 equals 3x. X equals 7. A whole number is a really good sign. Let's do our due diligence and plug this back into the equations to check. So 3 amounts of 7 minus 9 equals 4 amounts of 5 on 2 plus 2. 21 minus 9 is 12. 4 amounts of 5 on 2 plus 2 is also 12, so that one works. Let's double check with the other equation just to be certain. 6 amounts of 7 minus 2 minus 10 amounts of 5 on 2 minus 5 is 42 minus 2 minus 25 minus 5. So that's 42 minus 32, which is 10, and that is exactly what we expected. And so our answer here can be expressed as 7, 5 on 2. Let's graph. Okay, and if we look at where they cross, we're at the point 7, 2.5, or 7, 5 over 2, which is exactly what we said it would be. I'm not even going to try and be fancy. I'm just going to brute force this. I'm going to rearrange each of these into y equals, and I'm going to use the very first substitution technique I showed you. We say y equals y, which means the thing y equals the thing y equals, and then we solve for x. So that's 1 and that's 2. And I'm going to get 1 star and 2 star, and each of them are going to be in the form y equals mx plus b. So 1 becomes 10x minus 5y equals 7x plus 1, which means negative 5y equals negative 3x plus 1, which means y equals 3/5 x minus 1/5. This is 1 star. 9x plus 3y equals 5x minus 5y plus 60. The 5y over here becomes positive. Here we have 12. Sorry, no, hold on. That gets added to the 3y. That's 8y. Subtract the 9, so we have negative 4x plus 60. Divide everything by 8, we get negative 1/2 x plus 60 over 8 is 30 over 4 is 15 over 2. Okay, and so that is 2 star. Y equals y, or in other words, 3/5 x minus 1/5 equals 1/2 x plus 15 over 2. Now I'm going to multiply both sides by 10. This means that the ones that are divided by 5, those denominators will disappear, and there will be an extra factor of 2. They will get doubled. And the ones divided by 2, those denominators get disappeared, and there will be an extra factor of 5, so they will be quintupled. So we're going to end up with 6x minus 2 equals 5x plus 75, which means x is equal to 77. I don't like that number. It gives me bad vibes, but let's see. So that's equation 3. 77 can't be divided by 5 or 2. Really don't like this. I'm going to go into equation 2 star. So we have y equals negative 1 over 2 times 77 plus 15 over 2. So negative 77 plus 15, 77 minus 15, 62. Negative 62 over 2 is negative 31. Okay, let's check this with 1 star just to be sure. So equation 1 star says negative 31, right? That's our y equals 3 over 5 times 77 minus 1/5. So 77 times 3 is 210 plus 21, which is 231. That's over 5, and then we subtract 1/5. So we have 230 over 5. 5 goes into 200. Well, this is obviously a positive number, so something's gone wrong, right? Because it's meant to equal negative 31. Not going to happen. So let's go back. Let's check our working systematically. Firstly, have we got the right 1 star? So 10x minus 5y equals 7x plus 1. Subtract 10x from both sides. Divide both sides by negative 5. Good. Okay, I'm happy with that. 1 star is correct. Okay, for 2 star, let's see. So 9x plus 3y equals 5x minus 5y plus 60. 5 times 12 is 60. Good. So then add 5y to both sides. We get 8y on the left. Subtract 9x from both sides. We get negative 4x on the right plus 60. Divide by 8. Negative 1/2 plus 15 on 2, because 8 times 7.5 is 60. Okay, 2 stars, fine. So then where we've set them equal, we've got 3/5 x minus 1/5 equals 1/2 x plus 15 over 2. Then we multiplied everything by 10. So the left-hand side should become 6x minus 2, and the right-hand side should become 5x plus 75. I'm quite confident in that, which means subtract 5x from both sides. We get x on the left-hand side, add 2, we get 77 on the right-hand side. I'm fairly sure that x should equal 77. So what's gone wrong? When we substitute that into 2 star, we have minus 1/2 77 plus 15 over 2. Negative 77 plus 15 is going to be negative 62. And if that's halves, that's a negative 31. But when we check that in equation 1 star, it tells us negative 31 is equal to a positive number, which is obviously impossible. Let's try plugging equation 3 into 1 star and see what 1 star wants. So y equals 3/5 of 77 minus 1/5. So that is 231 over 5 minus 1/5, which is 230 over 5, which is 46. I found the mistake, or I found a mistake anyway, which is that this should be a negative 1/2 x up here. So let's try this one more time. So multiplying both sides by 10, we're going to get 6x minus 2 equals negative 5x plus 75, which means 11x equals 77, and this looks way more promising. X equals 7. So that can be our equation 3. Let's substitute 3 into, doesn't really matter, does it? I'm going to go with 2 star. So we have y equals negative 1 over 2 of 7 plus 15 over 2, which will become 8 over 2, or 4. Now, let's take this and substitute it back into 1 star. So if this is true, that means that 4 will be equal to 3/5 of 7 minus 1/5, which is 21/5 minus 1/5, which is 20/5, which is indeed 4. And so at this point, we can give our answer where x is going to be 7 and y is going to be 4. Let's graph this bad boy. And we can see that our point of intersection is at 7, 4. Sweet. All right, so that's a bunch of examples. I'm really glad that a couple of them went wrong because it meant that you were able to see how I catch my mistakes. And then you were able to see that when you find a mistake, you can just go back, you can figure out what went wrong, and you can get the right answer. Now, these were all examples of what I would call pure mathematics, which is we're doing simultaneous equations. We were given 2 equations and we just followed the steps until we got an answer. The next examples that we're going to look at here are worded problems, which means that they're going to be a little bit more annoying because we have to figure out what the equations are to start with. In my experience, for a lot of students, this is the hardest part, taking the questions and figuring out the equations. Dude has 8 trucks. Some can carry 10 tons and some can carry 5 tons. The first thing I'm going to do, and you're probably not going to like doing this because it's a lot of writing without making a lot of progress, but it's really important for helping you clear your mind and clarify what you're talking about. I'm going to define some variables. Let T be the number of 10-ton trucks. Let F be the number of 5-ton trucks. So we know that he has 8 trucks, which means T plus F equals 8. This is our first equation. See how easy that is? Once you define a couple variables, if you figure out what is important, the equations often become very easy to form. Now, secondly, we know if he fills all of these, so if he has 10 tons in each of these trucks, so if he has T trucks that each have 10 tons in them, and he has F trucks that each have 5 tons in them, in total, he's going to have 70 tons. Here's our second equation. This means F is equal to negative T plus 8, and I'm going to substitute that into the second equation. So 10T plus 5 times negative T plus 8 equals 70. So that's 10T minus 5T. So 5T equals, and then that's going to be equal to 70 minus 40, right? Because we do the 5 times the 8 is 40. We subtract it from both sides. So 5T is going to be equal to 30. In other words, T, the number of 10-ton trucks he has, is 6. He has 6 10-ton trucks. If T is 6, can you tell me what F is? I think it's pretty easy. Let's double check. 10 times 6 plus, which is 60, plus 5 times 2, which is 10, equals 70. All right, cool. I'm happy. So we have one step left, which we need to do, which is to answer the question we've been asked. So we say he has 6 10-ton trucks and he has 2 5-ton trucks. Cool. All right, next one. Tickets to a movie cost $15 for adults and $12 for children. If 1,000 people paid to see a movie and the total money paid was $13,800, how many adults and how many children were there? Okay, so I'm going to start this in almost exactly the same way. Let A be the number of adults and let C be the number of children. There's 1,000 people, which means A plus C equals 1,000, or as we're going to do in a second, A is going to be negative C plus 1,000. This is our first equation. Our second equation is that the total money paid is $13,800, which means if we have $15 paid for every adult and $12 paid for every child, that's going to total $13,800. So let's substitute in this A value. So 15 times negative C plus 1,000 plus 12C equals 13,800, which means minus 15C plus 15,000 plus 12C equals 13,800, which means we're going to have negative 3C here, and then I'm going to subtract 15,000 from both sides, which is going to give us negative 1,200 over here, and that's going to tell us that C is equal to 400. There are 400 children, and since there are 1,000 people in total, the number of adults is going to be 1,000 minus 400, or in other words, 600 adults. So let's answer the question. There are 600 adults and 400 children. Okay, let x be the numerator and y be the denominator of a fraction. We already have our terms defined. The denominator is 5 more than the numerator, which means the denominator is 5 more than the numerator. If 2 is subtracted from both the numerator and the denominator, so that means x becomes x minus 2 and y becomes y minus 2, then the denominator is twice the numerator. In other words, the denominator, y minus 2, is twice the numerator, x minus 2, or y is equal to 2x minus 2. Right? Because this becomes a minus 4, but then we add 2 from the left-hand side, we get that guy. All right, so to solve this, we can say y equals y, or 5 plus x is equal to 2x minus 2. Let's subtract x from each side and add 2 to each side. We get x is 7. Therefore, according to this guy, y is going to be 12. And according to this guy, y is going to be 12. So we can be pretty sure that our answer is 7/12. Or to answer the question, actually, the fraction is 7/12. One thing you see a lot of with simultaneous equations are financial mathematics, because you might have a line representing the costs of a business, and then you could have another line representing the revenues of the business. Where those two lines cross is called the break-even point. It's the point at which the revenues, the amount of money coming in, equals the cost, the amount of money going out. then on one side of that break-even point, the business is profitable, and on the other side of that break-even point, the business is not profitable. It is losing money. And so we can use the mathematics of simultaneous equations to find the break-even point. So Julian buys a coffee cup for $15,000. His repayments work out to be $80 per day for the first year. He calculated it will cost him $2 per cup of coffee for the ingredients. He sells coffee at $4 per cup, and he sells X cups of coffee per day. Fun fact, after crude oil, coffee is the most traded commodity in the world. And with a quick Google search, it looks like $2 as the cost price for a cup of coffee is probably about right as well. So this is a pretty realistic question. Okay, so write the cost function C and revenue function R. So every day, his costs are going to be $80. That's flat. That's him repaying his coffee cart. Plus, he's going to spend $2 for every cup of coffee that he sells. His revenue is just going to be $4 for every cup of coffee that he sells. So to find the break-even point, we need to solve these as simultaneous equations. Now, C and R are different letters to Y. But if we graph these are both going to be y. It's going to say y equals 80 plus 2x, and it's going to say y equals 4x. So that means 4x equals 80 plus 2x. In other words, 2x equals 80, or x equals 40. This means that if Julian doesn't sell 40 cups of coffee in a day, he's losing money. If he sells 40 cups of coffee, he's breaking even, meaning that he has the same amount of money he had yesterday. He didn't gain any, and he didn't lose any. So he wants to sell more. Now, the profit function is revenue minus costs. In other words, 4x minus 80 plus 2x. So if he wants to figure out what his profit is, he's going to do 2x minus 80, okay? This is going to equal 0 at the break-even point. I'm going to graph all of this stuff real quick. Our revenue and our profit functions are parallel. They will never touch. The important detail here is to notice that the break-even point, where the revenue and cost functions cross, that is equal to where the profit function crosses the x-axis, right? The x value, the number of cups of coffee sold in both cases, is 40. Now, the next question that we're asked is, what is his profit if he sells 100 cups in a day? So if we find where x is 100, we can see that his profit on the profit line is 120. But we don't want to be solving this graphically. We want to be solving this algebraically. So algebraically, we would say profit equals 2 times 100 minus 80, and then that will equal $120. Okay, we've defined what simultaneous equations are. We've looked at how to solve them with what's called the substitution method. We've looked at how to solve them with what's called the elimination method. We've looked at a bunch of pure maths examples, and we've looked at a bunch of worded problems. What I would like to do right now is clarify for you that you've been doing simultaneous equations for a long time without knowing it. And that has to do with every time you've had a question that's asked you to find the x and y intercepts of a function or of a graph. Basically, we take some equation and we solve it simultaneously with the equation x equals 0. So we just substitute in x equals 0. That gives us the y-intercept. Or if we substitute in y equals 0, then that gives us the x-intercept. Let's think about that really quickly for a second. So if I take 2x plus 3y equals 10, if I put in x equals 0, notice that that is the y-axis. See? That is the y-axis. So when I find where these two lines cross, it's going to tell me where 2x plus 3y equals 10 crosses the y-axis. Similarly, if I made this y equals 0, that is the x-axis. So when I solve them simultaneously, they're going to tell me what is the x-intercept. This is actually really, really useful to understand because we do this all the time, and sometimes it can get confusing. You can forget, if I want the y-axis, what do I set to 0? Well, you have to understand the y-axis is where the line x equals 0 sits. Everywhere on that line, x is equal to 0. Similarly, the x-axis is where y equals 0. Everywhere on that line, y equals 0. So let's look at a couple quick examples. In this case, if I want to find the y-intercept, I'll set x equal to 0. 2y plus 3, 0 equals 10, which is going to mean y equals 5. There we go, y equals 5. And then if I set y equal to 0, 2 times 0 plus 3x equals 10, which means x is going to be equal to 10 over 3, which will be 3 1/3, or 3.3 repeater, which we can see right there. Easy. All right, so for this one, if I want to know the y-intercept, I set x equal to 0. So y equals 0 squared minus 0 minus 6. In other words, y equals -6. And if I want to know the x-intercept, I set y equal to 0. So 0 equals x squared minus x minus 6. Now there's a bit more work involved here. This is a quadratic formula, and we can solve this equation by factorizing it. We're going to have x minus 3 times x plus 2 equals 0, which means x minus 3 equals 0, or x equals 3, and x plus 2 equals 0, or x equals -2. So let's graph this. So our y-intercept here is at -6, which is what we found right there. And our x-intercept should be at -2 and +3. There's -2 and there's +3. Cool. I just wanted to go over that really quickly because you've been doing simultaneous equations for years and they just haven't been called simultaneous equations because they're like the easiest possible version and your teachers didn't want to scare you. But now you know. You've done this for a long time. Okay, I want to jump into some higher order equations, which means that I'm going to have a straight line, a linear function, and I'm going to have a nonlinear function, something squiggly or curvy. I'm not going to do anything super fancy here. I'm going to stick to parabolas, hyperbolae, and circles slash semicircles, which you will see some of. All right, so for the first example here, y equals y, which means x squared equals 5x plus 6, which means x squared minus 5x minus 6 equals 0, minus 6 plus 1, x minus 6 times x plus 1 equals 0. Therefore, x will be equal to -1 or 6. Now, if x is -1, y is equal to x squared, which is 1. Or if x is equal to -1, y is equal to 5 amounts of that plus 6, which is also 1. Okay, if x is equal to 6, y is equal to x squared. Hold on, let me get the first one down. -1, 1. This is one answer. We're going to have another answer, which is when x is equal to 6, y is going to be equal to 36, which we can think of as x squared or 5x plus 6. So we have two answers to this question. And let's understand why that is. So you can see that there are two places that we're crossing here. The first one is here at -1, 1, and the second one is at 6, 36. So we found two intersections in our working out here. Okay, next one. X plus y equals 15. Okay, so that just means y is -x plus 15. So we can say y equals y, or -x plus 15 equals x squared minus 6x plus 1. So 0 is equal to x squared minus 5x minus 14. 14, 7, and 2. I'm going to make it -7 and +2. 0 equals x minus 7, x plus 2. Therefore, x is equal to -2 or +7. So we've got two answers. One is going to start with -2, one is going to start with 7. If x is -2, to get 15, we need to add 17. And if x is 7, to get 15, we need to add 8. Let's check this guy. So we're going to have -2, 17, and 7, 8, which is exactly what we got. Fantastic. Y is x minus 3. I'm going to substitute that in. So we're going to have x times x minus 3 equals 10. X squared minus 3x minus 10 equals 0. 5 and 2, -5 and +2, x minus 5, x plus 2 equals 0. Therefore, x equals -2 or 5. And so our two answers will look like this. If x is -2, y is that minus 3, so that's -5. And if x is 5, then y will be 2. -2 times -5 is +10. 5 times 2 is +10. We are good. Now, I want to graph this one as well. We just looked at a few parabolas. This did have a quadratic for us to solve, but that second equation is not a parabola. It is a hyperbola. So we have these 2 points, -2, -5, and 5, 2. Okay, x squared plus y squared equals 10. You should recognize this is a circle. Okay, so if we have a circle, there are a couple possibilities. One is that our line doesn't touch it. We'll get no solutions. One is that our line goes through the middle of it. We'll get 2 solutions. The third possibility is that our line is tangent to the circle, in which case we get 1 solution. So this is y equals 2x plus 1. I'm going to substitute that in now. So x squared plus 2x plus 1 squared equals 10. X squared plus 4x squared plus 4x plus 1 equals 10. 5x squared plus 4x minus 9 equals 0. 5 times -9 is -45. I want two factors of 45 that have a difference of 4. 5 and 9. Okay, 9's got to be positive because we want a positive 4. So we're going to have 5x squared plus, minus 5x plus 9x minus 9 equals 0. 5x, x minus 1 plus 9x minus 1 equals 0. So 5x plus 9 times x minus 1 equals 0. So for the second bracket here to be equal to 0, that means x equals 1. The other option is 5x plus 9 equals 0, so 5x equals -9, so x equals -9 over 5. Okay, so we've got two answers. One is going to start with a 1, one's going to start with a -9 over 5. Y minus 2 times 1 equals 1, so let's add 2 to the other side, y equals 3 in that case. In the second case, y plus 18 over 5 equals 1, which means y equals -13 over 5. Okay, let's check our answers. If we zoom right in, we have this intersection at 1, 3, good. And we have this intersection at this funky point, -1.8 and -2.6. 9 divided by 5 will be 1.8, and it's negative. And 13 divided by 5 will be 2.6, and it's negative. So we have the correct answer. And so now we've looked at an example of a parabola, we've seen an example of a hyperbola, and this is an example with a circle. We have a few more, though, so buckle up. So top guy here says y is equal to 2x minus 1. We substitute that in here. We're going to have 3 amounts of 2x minus 1 squared minus 2x minus 1 minus 2x squared. That's equal to 0. Let's expand these brackets out. 3 times 4x squared minus 4x plus 1 minus 2x plus 1 minus 2x squared. 12x squared minus 12x plus 3 minus 2x plus 1 minus 2x squared. So we've got 10 amounts of x squared, -14 amounts of x, and then plus 4. 40. 10 times 4 is 40. -10 and -4. So I'm going to have 10x squared minus 10x minus 4x plus 4. So 10x times x minus 1 minus 4 times x minus 1. 10x minus 4 times x minus 1. Therefore, x is going to be equal to 1 or 4 over 10, which is 2/5. If x is 1, then y minus 2 plus 1 equals 0, which means y is going to be equal to 1. And if x is 2/5, y minus 4/5 plus 1 is equal to 0, which means y is negative 1/5. Let's check those answers. Wow, would you look at that? That is a funny shape. What is that shape? I was honestly expecting a circle here. That's a really interesting shape. It's kind of like a hyperbola that's been tilted. I don't know what to call it. Anyway, we have this point here, 1, 1, and we have this point here, which is 2/5 and negative 1/5, which is exactly what we expected. So we're killing the game. This one tells us y is equal to negative 3x plus 11. Therefore, 2x squared minus x negative 3x plus 11 minus negative 3x plus 11 equals 10. 2x squared plus 3x squared minus 11x plus 3x minus 11 equals 10. So we have 5 amounts of x squared, we have negative 8 amounts of x, and negative 21. 5 times 21 is 105. That is 7 times 15. So I'm going to say 5x squared minus 15x plus 7x minus 21 equals 0. 5x times x minus 3 plus 7x minus 3 equals 0. So we're going to have 5x plus 7 times x minus 3. And that tells us that x is going to be equal to 3 or negative 7/5. First answer starts like that. Second answer starts like that. If x is 3, then that means 9 plus y is 11, so y must be 2. And if x is negative 7/5, that means negative 21/5 plus y is 11. In other words, y is 11 plus 21/5. 11 itself is 55, so add 21, that's 76/5. When I graph this, I'm going to expect this to be negative 1.4, and then this is going to be 15.2. Let's see what we get. This is funky business here. Wow, look at that shape. All right, we have two clear intercepts. We have one here at 3, 2. Excellent. And the other one way up here at negative 1.4, comma, 15.2, which is exactly what we were hoping for. Well done. Pat on the back. X plus y equals 5. Therefore, y equals negative x plus 5. So we have 3x squared plus x times negative x plus 5 minus negative x plus 5 squared equals 29. 3x squared minus x squared plus 5x minus x squared minus 10x plus 25 equals 29. So that's 2x squared plus 5x minus x squared plus 10x minus 25 equals 29. We have x squared, thank goodness it's a monic for a change, makes it easier, plus 15x. Negative 25 minus 29 is minus 54. So what adds to 15 and multiplies to 54? Well, it would be 7 and 8 if it multiplied to 56, but it doesn't. What adds to 15 and multiplies to 54? 27 and 2, obviously not. 3 and 18. 3 and 18. So it's going to have to be a positive 18 and negative 3. So x plus 18, x minus 3 equals 0. Therefore, x equals negative 18 or 3. So we're going to have two answers. One's going to start with negative 18, x plus y equals 5. So that means we're going to need to add 23 onto that. And then we're going to have one that's 3, which means we only need to add 2 onto that. So let's graph these and see if we're right. Our points of intersection are at 3, 2 and negative 18, 23. Yes. This time, just to make it easier, I'm going to solve for x instead of y. So x equals negative 2y minus 8. So this will become negative 2y minus 8 times y equals 8, which means negative 2y squared minus 8y minus 8 equals 0. Now I'm going to divide everything by negative 2, so we get y squared plus 4y plus 4 equals 0, which means this is y plus 2 all squared, which means y is equal to negative 2. And because it's squared, it essentially means we have the same answer twice. But if we substitute that into our equations, in both cases, it's going to require x to be negative 4. What this means is we're going to have a straight line that touches a curving line tangentially. Let's have a look at that. And so here we can see that tangential point of contact at the point negative 4, negative 2, which is exactly what we expected. Well, I can see that this is a circle with a radius of 5. How do I want to do this? Y is 4 on 3x. So x squared plus 16 on 9x squared equals 25. Which means 25 on 9x squared equals 25, which means x squared on 9 equals 1, which means x squared equals 9, which means x could be equal to plus or minus 3. If x is negative 3, then we have 3y plus 12 equals 0, which means 3y equals negative 12, which means y is negative 4. And if y is positive 3, we have 3y minus 12 equals 0, which means 3y equals 12, which means y equals 4. Let's graph this. And we have our 2 points of intersection here at -3, -4, and at 3, 4. Perfect. 2 more to go. X equals -2y plus 3. So that means we have -2y plus 3 times y plus 2 amounts of -2y plus 3 plus y equals 4. So we will have -2y squared plus 3y minus 4y plus 6 plus y minus 4 equals 0. -2y squared, then the 3y plus y minus 4y will cancel, and then we have 6 minus 4, so plus 2 equals 0. I'm going to divide both sides by -2, so it's going to become y squared minus 1 equals 0, which is a difference of two squares. Y plus 1 times y minus 1 equals 0. Therefore, y is equal to -1 or 1. So we have one answer that starts that way and one answer that starts that way. If y is -1, x minus 2 equals 3, so x must be 5. If y is positive 1, x plus 2 equals 3, so x must be 1. Let's graph these two equations and see if we're right. Let's see. 2 points of intersection. One of them is at 1, 1, and one of them is at 5, -1. Whoa, what did I do wrong? Aha, I solved for y first, and then I wrote it in as my x value. Let's take a step back and just go through this last step one more time. I have two answers. One of my answers is going to look like this, and the other answer is going to look like this. If y is -1, we have x minus 2 is 3, so x is 5. And if y is positive 1, we have x plus 2 is 3, so x is 1. Those are the answers we're looking for. I'm glad we checked that, because that's an important detail. I went on autopilot because in every question I've solved for x first so far, but in this one I solved for y first, and I didn't account for that. This one gives me that y is equal to -3 on 2x plus 1 on 2, x times -3 on 2x plus 1 on 2, plus -3 on 2x plus 1 on 2, all squared, minus -3 on 2x plus 1 on 2 equals 8. -3 on 2x squared plus 1 on 2x minus 3 on 2x. No, I need to square those brackets. So plus 9 on 4x squared minus 3 on 2x plus 1 on 4 plus 3 on 2x minus 1 on 2 equals 8. So collecting our like terms, we have -6/4 x squared plus 9/4 x squared. That leaves us with 3/4 x squared. Half an x minus 3/2 an x is a negative x, plus 3/2 an x is a positive half x. And then in terms of our constants, we have a quarter minus a half, that's a negative quarter, minus 8. So -8 1/4, which is -33 quarters. That equals 0. Now I'm going to multiply everything by 4 to make this a little bit nicer. So I'm going to have 3x squared plus 2x minus 33 equals 0. So I want two numbers that multiply to -99 and add to 2. 9 and 11, I would go with -9 and +11. So let's say 3x squared minus 9x plus 11x minus 33 equals 0. 3x, x minus 3 plus 11, x minus 3 equals 0. So 3x plus 11 times x minus 3 equals 0, which means, therefore, x is equal to -11/3 or +3. So this time, it is the x value that I found, so I can put it in as the first coordinate. Now going back to our equation at the top here, y will be -3/2 x, so -9/2, plus 1/2, which is -8/2, which is -4. And then in the second instance, it will be +33/6 plus 3/6, which is 36/6, which is 6. I like those numbers. They look likely. And our points of intersection, we have 3 minus 4, and we have, what's that, -3.66666. 3 2/3 is 11/3. Fantastic. That means we have gotten all of these now. So we have just gone through heaps of examples. We did a lot of examples of pure maths with 2 straight lines. We did some worded problems, and now we've done heaps of examples with higher order equations. I want to go through a quick summary now. You should now know that solving simultaneous equations means finding coordinates which satisfy 2 rules simultaneously. You should also now know that we have solved simultaneous equations for years whenever we have found x and y intercepts of a line or a curve. You should now be able to solve linear simultaneous equations using the substitution method or the elimination method. Similarly, you should be able to solve worded problems involving simultaneous equations. You should be able to solve simultaneous equations involving parabolas, semicircles, circles, hyperbolae, all of those non-linear shapes we looked at. For this week, please complete the given worksheet as a practice test. If you would like more practice questions, I recommend you start by reattempting any that you've gotten wrong. It's also worth trying to make up your own. ChatGPT is worth asking, although you can't necessarily trust it to give you questions that will work. One thing to look out for is if you have to find the simultaneous solution of two equations that have the same gradient, you will find no answer because those two lines are parallel. They never cross, so there is no solution to both of them simultaneously. Also, you can't trust ChatGPT to give you the correct answers. We've looked at various strategies for checking your answers, so you should not need to rely on anything but your own ingenuity. Next lesson, I'm going to start introducing the concept of functions, which is a word I've used accidentally a few times already, but this is going to lay the foundations for us to move towards calculus, which is the highlight for sure of year 11 and 12 advanced mathematics. If you don't count trigonometric identities, which I also think are pretty cool, but calculus is the coolest. Now, I want to put in some bonus material right at the end here. I want to cover what is called a matrix. For linear simultaneous equations, there's another method, which is a fancy version of the elimination method, really, and it uses a mathematical tool called a matrix. Yes, as in the matrix, because a matrix is a tool used in computer science, and it's used for a lot of things, including apparently simulating the reality that we are stuck inside. In New South Wales, you don't need to know this method. In Victoria, you do need to know this method. I want to give you a chance just to see what it is, so I'm going to show some easy examples. Now, just so you know, matrices are typically used when you have more than two variables, right? An x and a y, or an m and an n. If you have an x, a y, a z, a t, an a, a b, a c, a d, an e, like if you have 100 variables, you want to use a matrix because, as you're going to see, it's pretty straightforward to use, and it stays just as straightforward no matter how many variables you've got. Let me show you how we do this. What we're going to do is we're going to write these out like this. We have our m variable, our n variable, and our thing that it's equal to. So we've got two m's, three n's, and that's equal to -4. We'll divide that with a line like that, 3 m's and 2 n's, and that's equal to -6. So I treat these rows as things like how I was treating equations, and I can add and subtract them. So what I'm going to do is I'm going to subtract the top row from the second row. So our matrix becomes, the top row will remain unchanged, but the second row is now going to have the top row subtracted from it. So that's a 1, that's a -1, and then this is going to be a -2. Now I'm going to subtract two amounts of the second row from the first, and you'll see that this is going to eliminate one variable. So that's going to become 0, 5, 0, right? 4 minus -4 minus two amounts of -2 is going to be 0. And we still have 1 minus 1, -2. Okay, this tells me I can now divide the first row by 5. So we have 0, 1, 0. That tells me that one amount of n is equal to 0. So I can add that to the second row. So I'm going to have 1, add 1 onto the -1, it becomes 0. Well, we're adding a 0, so that stays as -2. And so that satisfies both of these. 2 amounts of -2 plus 0 is -4. 3 amounts of -2 plus 0 is -6. That's our solution. M equals -2, n equals 0. So you can see there's a lot of working out to do with matrices, and you can get a lot of fractions involved as well, which can be frustrating if you're not good at your fractions. All right, if we apply the same method, we'll say -2, 7, 4, and -3, 5, -5. I want to add the second row, subtract the second row from the first. So that will become a 1, a 2, and a 9. And this will remain -3, 5, -5. Now I want to add 3 amounts of the first row to the second row. So we're going to say first row remains unchanged this time. That will become 0, 11, 22. Now the second row we can divide by 11. So first row is still 1, 2, 9. Second row is now 0, 1, 2. And now I'm going to subtract 2 amounts of the second row from the first. So we're going to have 1, 0, 5, 0, 1, 2. So this tells me that x is equal to 5 and y is equal to 2. So that's -10 plus 14, that is 4. That's -15 plus 10 is -5. Yep, cool, it works. Last example here. 1, 5, -13, 2, -1, 7. I'm going to subtract 2 amounts of the first row from the second. 1, 5, -13, 0, -11, 33. Let's divide the second row by 11. 1, 5, -13, 0. Let's divide it by -11. So that becomes a +1. That's a -3. And now we want to subtract 5 amounts of the second row from the first. 1, 0. -13 plus 15 is 2. 0, 1, -3. And so this tells us x is equal to 2 and y is equal to -3. So 2 minus 15 is -13. 4 plus 3 is 7. All right, so now you've seen a quick overview of matrices. I hope that it's clear to you that this is actually a really easy way to approach these problems. You don't learn this tool because you do need to understand how to do it without matrices, but you can see that matrices are very handy. And as we have more and more variables that we need to solve for simultaneously, these become more and more and more critical. They save more and more and more time. Cool. Good luck with your test this week. I'll see you next week. Next week, functions.